This is A2Pure. We're on chapter 7 and we're finding roots then of equations. Just a couple of examples where you need to be careful, where it looks like there might be a root, or looks like there might be a root and there isn't one, or it looks like, what's the other way around from that? Looks like there isn't a root but there is one. So there are several types of graph where this type of detection does not work. If there's root f of x equal to 0 at p, but f of x is greater to the left of p and greater to the right of p, so there if it's just touching, then you would, if you put in a number smaller than p, you're going to get a positive. If you put a number after p, you're going to get a positive. However, there is a root at p, and so you can't, you sort of miss it there because you don't realize that there is a root because it just touches and go back. Obviously then the opposite is the case here. Just before q, if you want, I think is what they've called this over here, just before q it's negative, just after q it's negative, even though it's negative before and after, there still is a root. The other example then is where you think there's going to be a root. So just before 0 it's negative, just after 0 it's negative, so you think it crosses the axis, but it doesn't because there's a discontinuity here. So this curve contains a discontinuity at this point. The curve does not move continually from one y value to the next. The curve never crosses the x-axis, so no root exists. However, just to the left of the y-axis it's less than 0, and just to the right of the y-axis it's greater than 0. So you might think there's one, but there's not because it's not continuous.